This video we're going to be looking at the settings for a function generator. Specifically we're going to be looking at the Agilent 33120A model. Now function generators are used to generate AC waveforms so that we can inject them into a circuit. Most function generators can do different types or multiple types of waveforms. The most common would be sine waves and square waves, but they can also do some other things like sawtooth or triangular waveforms or burst settings. We're just going to be looking at the basics today. And looking at the various different types of settings that we can change the voltage. We can change the peak-to-peak voltage of the waveform or the RMS voltage of the waveform, and we can also apply a DC voltage offset. So we'll look at doing each of those, and of course we can choose the frequency or adjust the frequency that the generator is putting out. So before we look at the actual function generator, I have a image of one here so we can clearly see the controls. So I want to point out the controls, and then we'll actually kind of demonstrate setting these. But to start with, of course, we have our power button to turn it on and off, and then over here you see that we have these lots of buttons on here, and these have different color codes on them. So you can see up at the top there's like AM and FM in a light blue sort of color, and a lot of labeling up here in light blue. Those are for some special applications we won't really be doing. But on the button itself, you can see like button number 1 here has a sine wave. Okay, so if you want a sine wave, then you would press the sine wave. If you want a square wave, you would press button 2. If you wanted a rectangular, or excuse me, a sawtooth waveform, you would press button 3. And so just the default mode there would be to just press those buttons, and you can change between a sine wave, square wave, and triangular wave on buttons 1, 2, and 3. Looking down here below that, we have button 6. We'll set the frequency or the amplitude or the DC offset. Okay, so you you can modify either the frequency. So if you want to change a frequency, you would of course start by pressing the frequency button, and then you could change the frequency. If you want to modify the amplitude, then you would select the amplitude, and if you wanted to apply a DC offset or change the DC offset or remove it, you would choose the offset button. So each one of these would allow us to actually go in there and modify the certain parameters of the sine wave. Now, I was talking about these numbers on the buttons. You see there's a green number beside each button. So if you wanted to change the frequency, one of the things you could do is you would press the frequency to make sure that that's what you were going to change, and then you would come over here to the button with the green on it, says enter number. And so what you would do is you would press enter number, and then you could press the numbers that are beside the buttons. So if you wanted, like you see right now on our display, I currently have it set to 10,000 kilohertz. And so to enter that in using the number, I've got to first select enter number, and then I would put in a 1. So I'd press the 1, and then I would press the 0, and then here's the period. So I would press this again to enter in a period, and then if you wanted to be very exact, you would press in like 0, 0 again. So you could be pretty precise with this. So you could do like, if you wanted to do like 1.5 kilohertz, you would put in a 1, well, you've got to remember, hit the enter number. I always forget that. You tell it you're going to enter in a number so it knows to use the buttons as numbers as opposed to changing the modes. And so enter number, and then you would put in, if we're putting in like 1.5, so I would put in 1.5, and then what we have to do, I'll have to scroll over here on the image there to the right. Now you see we've got 4 buttons here with some arrows on them, but over here they're also labeled with megahertz, kilohertz, or hertz. So remember, we needed to make sure that we were in the frequency. And then if I wanted to put in 1.5 kilohertz, again, I would do the enter number, enter in 1.5, but then I would select this button here to enter in kilohertz. Okay, so I would press this button to tell it that I'm putting in 1.5 kilohertz. If I press this button, I would be putting in 1.5 megahertz. Or if I put in or I press this button to finish it, I would be putting in 1.5 hertz. All right. So similarly, if we wanted to put in an amplitude, okay, or an offset, we would be putting in voltages there, and I would say, I would select the amplitude button, and then I would select my enter number and punch in the number 1.5 or whatever. But now you notice that we have over here, we have a peak to peak or a volt RMS, or they actually even have a decibel value that you could enter it in as a decibel. Okay, but so if you wanted to put in, say, 1.5 volts peak to peak, again, we would start by pressing in the amplitude, telling it that we're modifying the amplitude, not the frequency of the waveform. And then we would tell it, okay, I'm putting this as 1.5 volts RMS or 1.5 volts peak to peak. All right. So remember, if you wanted to put in a 1.5 peak, all right, you would actually have to put in something like 0.75 peak, or excuse me, a 1.5 peak. We would have to put in 3 volts peak to peak would be what we would have to enter in here, because we can't enter it in directly as a peak, so we have to double it to make it a peak to peak, or put in the RMS value and calculate, we would have to know the RMS value to put that in. But that's how we can put those in. Now another thing that we can do, which I'll demonstrate this here in a little bit on the actual machine, but there's a dial up here. And so what you could do is you could actually go in and like dial in the values. So when you look at that, you see these arrows here. We have a right arrow and a left arrow on these buttons. Okay, so what happens here is you kind of see like this 0 is a different color. It's actually flashing on the live box, and so it's kind of a different color at the moment because it's flashing on and off, so it's a little dimmer in there. That's where we're at. So what happens now is if I turn this knob, it will sort of dial in that number, and the number that it's going to change is this number here. So if I dial it clockwise, it's going to increase this number, so it'll go from the second digit here, because I'm at the second digit, that's the number it's actually going to change. So you can select which digit you're on using these arrows here. Right. And if we look all the way over here, there's these are where we have our connection. You see there's 2 of them. There's one called a sync, and then the other one is the output. The output is where you're actually going to output the waveform. All right, so when you want to connect your waveform into your circuit, you need to connect your connector that is going to output. You need to connect a BNC connector cable here to the output, which is the second one here. The sync connection is if you wanted to connect multiple scopes or function generators or whatever, and you wanted them to be synchronized. The sync connection outputs a timing signal so that it will sync them so that they will be in phase on there. So we, for the most part in this class, won't be using the sync feature in there, but that's what it is. So you need to make sure you don't connect up to the sync. You need to be connecting up to the output, which is this bottom connector here. Alright, so when we're selecting a cable to use with a function generator, we have to be careful we select the correct type of cable. So here we have two different cables. This cable right here has the BNC connection that will plug in to a function generator or to an oscilloscope. But the important thing is on the other end where we're going to connect it to the circuit. So you can see here on this cable we just have attached two alligator clips for connecting directly to a circuit. So this is going to allow the voltage to come through and pass a current directly in. This here connector is a special connector designed for an oscilloscope, and it actually has an resistor in here. It has attenuation in it, and so this is fine to use for an oscilloscope, but you certainly don't want to use this type of connector here for connecting up to a function generator to supply a voltage and a current into a circuit, because there's attenuation and special circuitry within this that's going to affect what you're trying to inject into your circuit. So you need to make sure that you're just using a straight cable with the BNC connector on here and some alligator clips. So I'm just going to take this and we'll connect this right in here to the output. So remember, the second connector is the output. The bottom one is our output connection. Okay, so I have the BNC connection with the alligator clips coming out of my function generator up here, and I also have the same type of connector plugged into my oscilloscope. Okay, and before I go too far, I want to point out to you here on the oscilloscope, you see that there's no connection. It's so what we have is we just have basically zero voltage, right? So the oscilloscope is just reading zero voltage there, and so right here in the center is the ground line of the scope. Now on oscilloscopes, we'll talk about that in a different video, but oscilloscopes, we can adjust the ground. We can make the ground higher or lower. And so right now I've got the oscilloscope set right to the center of the screen. There is the ground point. So that's the reference point, is the center of the screen. So if the voltage is above that, it's a positive voltage, and if it goes below that, it's a negative voltage. And so when I hook this oscilloscope up here now, I'm going to hook the ground connector to the ground connector, and then I'll hook the positive. I'll hook the positive to the positive, and then you'll see the sine wave on the oscilloscope. So now we have the function generator running, and you can see the function generator is running at 10 kilohertz, and it's a sine wave. So we can see down here on the oscilloscope here, there's a sine wave, And you can see that I've got the oscilloscope set up so it's showing us both the RMS voltage, which is 3.58, and it's showing us the peak to peak, which is 10 volts, and of course it's also showing us the peak, which is 5 volts, and it shows the frequency here, which is 10 kilohertz. Okay, and so if I select over here on the scope, or on the function generator, if I press the square wave, you can see that the output immediately changed therefore to a square wave. If I press the triangular wave button, it changes to a triangular wave. All right. So again, those buttons, you have the sine wave, square wave, rectangular wave, and more of a sawtooth wave if you choose the one button 4 here. I'm going to go back to sine wave, and we'll just be using a sine wave for here. Right now it's set on frequency. If I wanted to see what the amplitude setting was, I'll press the amplitude button, and you can see that the amplitude is 10 volts peak to peak, which is again is what we have it showing right here on the oscilloscope in the lower section. And if I select the RMS voltage, if I was to put it in as an RMS, so this is just going to change it, but if I wanted to put it in as RMS, I could do that. So remember so right now it's 3.58 volts RMS. So let's say I wanted to change the amplitude, and I'm going to put it in as an RMS, and I'll put it in as, say, 3 volts RMS. So I'm going to hit enter number, and then I'm going to put in 3, and I like to go ahead and hit a period and put in a couple zeros to try to make it as accurate as possible. 3.00, and then over here I'm going to press the vrms button, so that's the down arrow. Okay, and so I press that, and now you can see down here in the oscilloscope, you can see that it actually says 3 volts RMS, which is only like 8.8 volts peak to peak. So as soon as I pressed that button, then it went there. Now you can see the dial, the flashing. You can see the 0 right after the 3 is flashing. That's what this knob is set at. So as I dial this, you can see that it's increasing or decreasing the waveform, and we can see that down in the lower screen. You can see the waveform getting a larger peak or a smaller peak, and so we can just kind of dial it in there. And if I use the arrow keys here, if I move it over to the left, now I'm increasing the larger magnitude, the more significant digit on there. So we can use this, and then if I wanted to be a little bit more accurate, I could dial it in just a little bit, so I can kind of dial it in with this dial knob up here at the top. Same thing if I wanted to flip back over to the frequency, and I can dial up the frequency, and you can see as we increase or decrease the frequency, you can see it expanding down below. If we wanted to set the offset, I'll click over here to the offset. Now right now the offset is 0, which means that the sine wave is perfectly centered on the scope there. Get a better picture of the scope, or of the sine wave on the scope there. If we point it up here a little bit so we can see the sine wave, and the sine wave has no DC offset, so it has just as much on the top as it has below the ground. So remember again, the ground, if I disconnect it, the ground is that bold white line going across there. That's my ground reference at the moment. You can kind of tell that by this little 1 tag over here. to the far left, it shows you your ground reference. So now if I was to dial in some DC offset, I still have the exact same sine wave, but it's now all above that zero reference. Now what you're seeing here is you're seeing this thing down here in the oscilloscope. You see that the sine wave kind of went out of whack. Instead of it holding it constant, it's out of whack. Now that has to do with setting your trigger level on the oscilloscope, which we'll cover in the oscilloscope video. Okay, but right now the level is set at 0. If I raise my level, I can kind of stop the sine wave from scrolling around, and it looks like it's captured the picture. All right, but that's due to triggering on the oscilloscope, and it had nothing to do with the function generator. So if I drop my trigger level back down to 0, then it starts kind of, the scope's going out of, looks like it's kind of out of sync or something. But if I dial this down, I can also dial it down so that my sine wave is entirely below 0. So I have just a negative voltage here, but it's a AC waveform riding on a DC constant. Okay, so again, I could just enter this in as a number. All right, we can just always type in the offset by typing, say offset, enter number, and I'm going to enter the number 1.2. So 1.2, and if you wanted to add a couple zeros, that's fine. And then again, you got to select whether it's RMS or peak to peak or whatever, but since it's DC, it would just be like an RMS. All right. So you could see now though that it has jumped. And then if I go enter number and I just want to put in 0.0, put it back to 0 for my DC offset. So that's how we can set the function generator. So when you first come into lab and you want to use the function generator, you're going to start out, you have to set a frequency. So you come over here, you set your frequency. If it's close, you can dial it in, but if the default, the frequency that it came up on is way off, again, you can just punch in a number. So if I wanted to put, say, 200 hertz in, I would select frequency, enter number 200, and then you would select either hertz for 200 hertz, or you could select, again, enter number 200 and hit kilohertz if you wanted kilohertz. So that's how you enter it. And then you would also want to set your amplitude. So if you wanted 5 volts peak to peak, so I would enter in, I would make sure I'm on amplitude, and I would select enter, and I would put in, what I say, 5 volts, 5.00, and then you would select either peak to peak or RMS, depending on which one you were trying to get. Okay. And then, let's see, that was, I think I had 200 kilohertz. Let me just go to 2 kilohertz. So I'm going to say enter number 2, and I'm going to just put in kilohertz. Okay. And so we can see our sine wave there. We have a 2 kilohertz sine wave with 5 volts peak to peak. Now if you notice down here on the oscilloscope, you see that it's not, the scope was telling us that it's not quite 5.00. So if we looked here, it said 5.00. But the oscilloscope, I would trust the oscilloscope over the function generator. All right, so you always want to check with your scope and when you're doing your readings in lab and measure that. So in this case, it's a little bit, the scope is saying it's not 5.00, it's 5.12. So I would actually just dial that down now till the scope is a little bit closer. So again, we can arrow over and we can dial it down kind of slowly. Till the scope is 5.01, 4.98, something like that. And you see it's bouncing around a little bit there. Okay, so you know, it may fluctuate a little bit, but as long as we're pretty close there on there. But we want to use the reading on the scope, because that's what we're going to be measuring all our voltages by, is the scope. And so we want to make sure that we use the scope to set the voltage and to set the frequency. Don't use the you know, I mean, you can use the settings on the function generator as a set point to get there, to get near the value fast, but you may have to just make some slight adjustments so that the values are what the scope is telling you the value, and it may be slightly off on the function generator.